All right, hello everyone. My name is Timothy Lee Grant, and I said that I was going to go and investigate the sliding window problems. And one of the questions that I had was I was curious if when I investigated two pointers last week, so I intensely studied two pointers, and in specific, I didn't go and study a whole bunch of problems within two pointers. It was only four problems, and I wrote down all of my thought process. I wrote down everything that I was thinking about and uh, tried to make as many connections as I could, as many observations as I could, etc. So one of the questions that I had was, all right, does it generalize? And one of the things that I was thinking about doing was, okay, well, now I have this right here. I'm going through this Leetcode map. So I did two pointers. I did four problems intensely for the two pointers. So I'm thinking about moving down to sliding window. Well, sliding window seems to be a variation of two pointers because instead of like moving them in this direction or that direction, or sliding window is just moving them in this direction. So I was thinking like, okay, well, let me figure out if I can just see what I am able to come up with right now of just randomly picking, and I went here and I picked the first one. So let's just see if there's any like thing that comes to my head. So longest substring without repeating characters. Okay. Given a string S, find the length of the longest substring without duplicate characters. So we're given a string, and just like so I'm trying to make as many observations as I can. That's kind of the point right now, is we're making as many observations. We're trying to find, well, what information. We know that this is sliding window. What kind of problems does this solve? What connection can I make to two pointers, right? So, because I studied this intensely, okay, and I tried to make as many connections as possible. Now I'm studying this, and I'm going to try to study this intensely. Well, what characteristics can I find in common? So, trying to find as many observations as I can. The first thing that I see right here immediately is, well, when I was doing two pointers, it was asking about arrays. Many of the questions that they were asking were about arrays. And now here I'm getting another array problem. It is a string, which is what? A character array. Okay, so that's one observation. Now, I am looking at it, and what is it asking? Find the length. Okay, so length is when I was solving two pointers, many of the observations that I made were, hey, length is actually embedded within two pointers. And what I mean by that is I have a left pointer and a right pointer. Well, guess what? The length is just the location at this index minus the location at that index. So it is embedded within the two pointers problem itself, or the two pointers method itself. So you can find that length information by the two pointers. So I'm thinking, okay, well, I have this method of two pointers and it has longest. Okay, well, cool. I have a string or an array, and I want to find information about longest. Now, without duplicate. So this is kind of a constraint, right? Like, this is what I want to find. Okay, so I have my string here, and it's ABC, ABC, BB. And now the output is 3, and the reason is because the answer is ABC with the length of 3, okay? So what I'm thinking is I will have a pointer. So I'll start with both of the pointers here at the beginning, right? And I'm going to increase my pointer and say, all right, so my right pointer is now here at this B. And then I'm going to say, does that violate the rule? Does that violate this duplicate rule? If it's fine, then I'm going to say, okay, well, this is now my longest length. And then I'm going to try to come here and put my right pointer here and say, does this violate it? And if not, I'm going to say, this is my longest length, which is 3. Okay? And then I'm going to try to move one more. So I'm going to try to go here. Does this violate it? Well, yes, it does. So what do I do in that case? I guess I can move my left pointer now, right? Like this. Move it over by 1 and say, now does it fit the rule? And okay, well, now it does. Okay, so cool. Now I can move my right pointer over by 1. So now it's going to be like this and say, does this violate the rule? Well, yes, it does. So then I can move my left pointer over by 1. Now I have this and say, does it still break the rule? No, it doesn't. So it's okay. Is that longer than my current longest? No, it's the same, so it's fine. So then I'm going to try to increase the right pointer by here. Does this break the rule? Yes, it does. So then I move over the left. Does this break the rule? No, it doesn't, but it's not longer than my current longest, so just don't update it. Then I'm going to say, okay, cool, so I'm going to try to move my right pointer over by 1. Does this break the rule? Yes, it does. Okay, so now I'm going to move my left pointer over and I'm by 1, and I'm going to have this. Does this violate the rules? Yes, it does. So I'm going to move my left pointer over again. So I'm going to come here. Does this violate the rule? Yes, it does. Or no, it doesn't, but it doesn't, it's not longer. Okay, so now I'm going to come to here. Does this violate the rule? Yes, it does. So then I'm going to come here. Does this violate the rule? Yes, it does. Now I'm going to move here. My left and right are pointed to the same one. And does this break the rule? No, it doesn't. So then I can move out. So that's kind of the way that I'm thinking about this. So I am going to have a left equals right equals 0. So they're starting here. And that was another thing in 2-pointers. I'm making as many observations as I can. In 2-pointers, we sometimes started where both of them were at the same. We sometimes started where one was at the beginning, one was at the end. Sometimes we iterated through each of the elements. Sometimes we radiated out, sometimes we radiated inwards. Now what we're doing is we're kind of moving kind of like this. Like they're moving in not lockstep together. They're not like this, but they're moving in jagged kind of motion. Okay? So kind of like that. And now I need some way of determining. So I need some way of determining if my rule is being broken. And now, so the obvious way that comes to my head is, hey, a set is a data structure that doesn't have duplicates, right? So right now I'm a little bit stuck on how to check the rule. Obviously, I know a set is going to have that property that I can check in O of one time, like, is A in my set, yes or no? But the question is actually like, hey, how do I now take that out? I can remove an element from my set, but if for example I have like B B B B B B B and I come here and then I put it in my set, and then I try to come here and I still put it in my set, well, in this case, right, like I come here and then I come here. I have an A here. I know that there's only, because I've gotten to this point, I know that there's only one other A in my list or in my window, because that's by definition the rule. So I know that I need to move my left pointer over by however many it takes until I reach the point where I find that other A. So here, it's immediate. I found the other A and I just loop it there. Okay, so I think I can use a set. So my set equals set. Okay, now if not s, return 0. Okay, otherwise, while, so here's another observation that I'm making. When do I terminate the while loop? So thinking about it, I want the s to, or I want to terminate when I come here. Let's just pretend that it's all unique, right? I come here, and once my right gets to this point, I don't need to continue checking, right? Once it gets out of bounds. So length of s. Length of s is equal to length. While left is less than length of s, and right is less than length of s. Okay? And this is the number of elements, and I want to stop when I'm out of bounds. So like s equals a, b, c, like this. And I want to stop when my right, and now I'm suspicious about this left part. So is there any time that my left can be ahead of my right? I need to think about that, and that's why I put this in here, because I don't know. And that's something that I'll need to investigate further. So 0, 1, 2, and I want it to run when right is equal to 2, because that means C. But when right is equal to 3, when right is equal to the number of elements, not the index, then I want it to stop. So I want it to run all the way. Yep. Okay. So cool. Now I am going to do what? I am going to check if my current right, so my right is what I'm adding. So if s of right in my set I want to do something, I don't know yet, else I want to increase my right by 1. Right The reason I'm hesitating on this is because I'm trying to figure out when I increase my right. I don't feel like it should really be there. Okay, so I don't know. Let's figure this one out. So if S of right is in my set, then what do I need to do? I need to move my left. So while S of left does not equal S of right, left plus equals 1. So I'm going to move my left over by 1. Yeah. So then otherwise, if I come here and then I come, so on the first iteration, I want my right, my left to be here. Current, so current longest is equal to 0. Okay, so I'm thinking I do right plus equals 1 up here because I want to move my right over by 1. And then I want to check, is it the same? But that means that I need to add my first one in already. So I need to go my set dot add S of right. Okay. And now, if it's not in my set already, okay. My set dot remove S of left. So I need to get rid of, because let's say I'm here and I just moved my left over by 1, right? I'm going to be moving my left over by 1, so I need to get rid of this where my left currently is. So I'm no longer at this A here for my left, so I need to get rid of that from my set. Okay. So otherwise, I'm going to do what? I'm going to check, like, if left, is it else? I think I can just do, like, if left or right minus left plus 1, and I remember this plus 1 from my 2 pointers. The reason is because I want to count elements. So, okay, this is actually a really good point about the connection that you can make between 2 pointers and sliding windows, right? Like I learned this technique when I was implanting those 4 problems of 2 pointers in my brain. Like one of the things that I noticed was, oh, where'd it go? Here, was, okay, well, what is the way in which you embed distance or length in 2 pointers? So 2 pointers, I said, has within its very method information about the length. Well, how do you actually embed that? It's right minus left. But then I realized, oh wait, there's a catch. Like if you are doing, if you want to know the space between them, it's left minus or right minus left. But if you want to know how many elements, like 1 element, 2 element, 3 elements, it's right minus left plus 1, because you have to account for where they actually are in the array. Like if my left is here and my right is here, I need to include both my left and my right. So left is 0, right is 2. So 2 minus 0 is 2. That's not what I want. I want 3 because there's 3 elements. That's where that plus 1 comes. So if this is, oops, is what? Is larger than current longest. Just to update current longest. Current longest is equal to this right here. Okay, that information. And then do we need to add this right to my set? I think we do. My set dot add s of right. Something like this. Return current longest. So this is kind of the way that I'm thinking about doing it. I'm not sure if it is correct, but I just wanted to give kind of an example before I actually go and, as I mentioned in my previous video where I was talking about my plan for moving forward with Leetcode, is I'm planning on tomorrow is to hardcore implant in my brain some of these problems of the sliding window. I'm going to try to make as many observations as I can. I'm going to try to understand those whatever 4 or 5 problems very deeply. But one of the questions that I had was, okay, well, did I actually learn? So I did 2 pointers, and I went through maybe like 4 problems. And then I was wondering, like, okay, well, did it actually help me? Was I able to kind of generalize it? Did I learn anything? And now, talking through this, I realized, okay, well, actually, yes, I did learn something. And I think that there is something to going through this very, just focusing on one topic and focusing on like just 4 problems and really understanding every point that you stumble on. So I don't know if I'm going to get this correct, but I realized that when I was doing this, I was able to make a lot of connections to 2 pointers from the sliding window, and I'm very like optimistic now about, not that this I don't know if this problem will work. I keep saying that, but I'm very optimistic about, okay, well, I think I'm on the right methodology for moving forward. So let's try it. Let's see if it works. All right, does it not like the remove? Yeah, okay, well, okay. Delete? I don't know. Is it like delete? No. Okay, well, that is just a syntax thing. How to remove element from set in Python. discard or remove. I thought that's what I just did, right? But it didn't like it. Yeah, it doesn't like that. If the element doesn't exist. Yeah, okay, so this is something that I'll need to go forward with tomorrow and really understand, like, okay, well, I'm tripping up on this. Something in my algorithm's wrong, there's some misunderstanding. Okay, cool. But I'm really, like, thankful and I wanted to kind of do a test to see, okay, well, I see a new problem. Did I use any of the techniques that I learned in the four problems previously? Was I able to kind of transfer information and techniques and over? And the answer is yeah, I was able to look at this and see connections between the two pointers problem and the sliding window problem. I was able to identify, like, okay, well, yeah, the two pointers method actually might be pretty useful. And so anyways, I will tomorrow. I'm going to be going through this problem, and going to be going through a whole bunch of other problems, like as I said, four or five, and I'm going to try to understand them very deeply. And I will keep you guys updated on my progress in Leetcode, and also doing whole bunch of other like back-end software engineering projects. If that is interesting to you, subscribe to this channel. And I hope you guys have a wonderful rest of the day. My name is Timothy Lee Grant, and goodbye.